Hi guys, this is part 2 of my video for the Flip32 all-in-one flight controller, and in this video I will show you how to build copter with this all-in-one board. And I built my custom ZMR 210mm frame with this board, and I will show something what I've done in this board here, in this frame, and how to connect this with the Flip32 here. This is another one, the latest version. It's 1.02. You get at the moment the 1.03, but they are the same, just a little different in connection from the gyro and the acceleration sensor, but this version has no problems anymore like the version 1 with BC output for the OSD chip that was burned in the first versions by too high voltage. And this version 1.02 is perfect. It works very well. Later I will show you how to flash it with latest Betaflight version and the latest MWOSD version, so that you can use this very well. In first step I will show a little bit from my frame. The first idea I had was to build something with my parts that I have from my old ZMR250. These arms, a lot of people have these arms here from the ZMR250 that is very successful in race quad community, and so it's very cheap. You can get two of these for I think $4, and a lot of people have this DIS 1806 2300 kV motors, very durable, very performant for use. So I'm looking for a reuse of these components, and I start to build for my 3D printer in frame, and can you show some iterations of this. I'm starting a layout that fits for the arms, and the problem was I have only a tiny ball printer, and this has only a printing area of I think 80 millimeters. So it must fit on my printer, and it must fit for these arms. So after a lot models I got a version that has 210 millimeters in diameter, so perfect for 5-inch props here and for these arms, so it works. And then I had need something that can hold my camera, so I create a holder for the camera that is fits perfectly with an PC 0420M camera, 600 TV lines, and I need something for my video TX. I want something for RGB LED and for Mobius. So I will show you later the details. So I had done a lot of things to test and try what will work, I found a good Mobius mount. This has the layout from the ZMR210 top plate, and I want to reuse this, and so on and so on. So I will show you some details of this copter. All files you see here are available at Thingiverse, so when you like to print it too, just do it. All files are public, you can reuse it, remix it. I would like to see some pictures when you have built one. I hope you like it. So just something more from my components. I used this new XM20A BL Healy ESCs. They work perfect. I had some old Emacs ESCs first for these motors, but they're stuttering, hang, and not very well. So buy some of these for $10, I think, and you will have a lot of fun, a lot of trust, and good performance. From the button, you see you just need some screws. I think this is 14mm screws, some lock nuts, and perhaps some rubber for the battery. I will use some 3S battery, 1500 milliamps, so something like this. That works very well, and I think you have about 8 minutes flight time with this. It's a little bit lighter than a full ZMR250, so it works very well. So I just unscrew some parts. This is something you must do when you want to config this all-in-one board, because you must switch something on the board. I will show you to connect the flight controller to the USB port, and in standard the flight controller is connected to the OSD in flight time. So the most configs you can do in the OSD menu, but for first config you must directly connect your USB with your PC and Cleanflight software, configuration software. So you see just 4 screws. Here are the standoffs. You see my D4R2 receiver, FreeSky receiver, and just 2 connections here. This is for the RGB LED here. So cables come with this, and for the video TX it's just 1 connection here, so I can remove this completely when I remove the receiver. And telemetry, this is just voltage divider for the analog telemetry port of this, so I can read the voltage on my FreeSky radio. And okay, so this is the upper part. You see it's nice, fits perfect, and you can remove it. RGB LED is very nice for race flights, so other people see your copter. And these are standard rubber bolts you get as replacement part, and these are things that I've designed to stop lost my rubber bolts. You find these files also at Thingiverse. So here some clips, and you can remove this part completely. So what you see here is the all-in-one flight controller, and the camera here. It's flexible. You have a screw to fix this angel, and here are the voltage divider for my radio, and here is the new Flip32 version 102 flight controller. Most of the things are the same like in my video part 1. So Here just some specials. You see the switches here, and at the moment the flight controller is connected to the OSD. This is the flight controller switch. This is the connection to the OSD, and these are the switches for the OSD when you want to flash this. So at the moment I can't connect it to my PC. If I want to connect it to the PC, I must remove the connection to the OSD here, and now I can connect it to the USB. When I connect, when I switch the first 1 and 2, then I have a connection to the USB and the OSD chip. Now I can flash it with the PC. I will show you later how this works. I had a buzzer connection. This is on the button. So here are the video, TX and camera connection. I connected minus, plus and signal to the camera and the video TX. Please have attention, and the plus serves the full LiPo battery voltage. So your camera must have support for 3S, 4S camera when you direct connect the voltage from the camera, from the LiPo to the camera, and also for the video TX. So my components I think allowed to use 6S battery. The camera allows to use 4S battery without any problem. So I can just solder it directly in complete connection. This is nice and clean, and I think you should use a camera that supports this also. So you can connect all this and use clean voltage from the LiPo here. And for other components, on this side we have the PPM connection to your receiver, motor 1 to 4 connections, just a signal I need here on these DRS EECs, and the other connection I had removed. These are for other motors, like on a hexacopter. On this side I'd show you there is an RGB port. On this is 4-pin out, but the cable just has 3 wires, and you only need 3 wires to connect your RGB LED. It's plus, minus, 5 volt, and then a signal line for configuration of the RGB LED. The other one is an UART2 connection for GPS when you have, but I don't use it on this. And this is an satellite receiver port. You can go with an S-bus connection to an S-port, S-bus receiver or satellite receiver or something else. I didn't have any one, so I didn't use this. Here this is UART1. You don't need it because all connections go already to the telemetry of the OSD and the USB. So I remove the standoffs to show you the button side of this and how easy it's to repair or to check this frame. So this is 35 millimeter. I had to remove this connection. Now I can move this up. You see here, this is the cable for the video TX. This is the cable for the camera. It goes to the front. This is the PPM cable. It's a lot of cables. Hope you can see it. This is the current sensor. It's already configured in the Cleanflight, and this is the buzzer connection. So just solder pins here, plus and minus, go to a standard buzzer 5 volt. Okay, this is everything you need to connect. Here are the plus. This is the plus side for the battery. On the other side, the minus is completely, but for the plus that you can use the current sensor, there's one port here and the other one are for the motor outs. So my LiPo cable goes through the frame here. I had opening here and just these straps for the use of the battery holder. So so this was the part for the components. I will show you in the next part some configuration video of how to connect these. So just for remember, in the first step I flashed the OSD, so I must switch up the first and the second pin here, and all the others are down. In the second part I will use a connection to the flight controller over USB. I just use the last 5 and 6 pin up, and now can I use Cleanflight via USB to this. So this is the first part, and the next I will show you some screenshots and videos from the PC. So my Flip32 all-in-one I got from Airbot shop, myairbot.com, and at the moment they have already the version 1.03. This the version that I have is a 1.02, but the only difference is in connection between the accelerator and gyro. In the latest Betaflight they fixed it, so you don't need it really. If you have a version 1.02, it's perfect, it will work very well. No difference in version 1.03 for your and your flight performance. The board is very good from pricing. You get free shipping here at Airbot when you order for more than $50. Very fast delivery. I recommend this. So in the next part I downloaded MWOSD, and this OSD is software, supports already Betaflight. You see the air mode activated in the OSD. You find the link in the description of the video, and when you have it, you have some parts I will show later. So the other one that you need is the latest Betaflight. In my video I saw the 2.3.4 version. I think the latest is 2.4 RC1, but when you watch the video, perhaps you see version 3 or something else. Just use the latest version when you download it. It will already fit. You need the NACE hex file. You find it at the bottom, this hex file here, and when you have downloaded the files, you see here in the OSD some folders, the MWOSD and the MWOSD GUI. First you need the MWOSD and folder, and there you find an inno file. This inno file you can use with the Arduino software, so you must all check that you have the Arduino software. Link is also in the description. You open it with the MWOSD AIO file, double click here and it open. So in the next part you must check that you have the right configuration, and you open the config H file, check that you have Cleanflight or Betaflight. In this version it's the same, but you can already use the Betaflight thing. Just uncomment it, For configuration, you see first we had the pins, and then you must use the Arduino Pro or Pro Mini as a board. And a second part for processor, you need 5 volt 16 megahertz here, and then you must connect the port. When you connect it to the USB, it's here at the moment COM3, and when it looks like this, you're perfect, and then you just need to upload this. Hochladen means upload. So Sketch is compiled and would upload it. Don't harm with the warning here. And after upload, you can use the GUI software for configuration. So I will check this here. You open the GUI folder and always use the Windows 32 version. That works without any problems, also on 64-bit Windows. Then you must check you have the right COM port. Just click on it, it will connect, and you see the full screen with all components here, but you don't need it for racing. So just check the right config for racing. First I will upload another font, so it's bold, I see it better, or large for bigger, so just check it here. This is with large, and when you select the bold, it's more visible, I think. So when you're choosing the one, just upload it. It need a little bit time. So I fasten it up. Whoa. So, and then the font is available. So I check this, restart the board if it's there, okay. And then I choose the config. First I need the main voltage from a flight controller, so these adjustments aren't needed anymore. It used the things from the flight controller also for the current, and then you can use RSI. Here is it needed that you use also the flight controller thing if you have configuration from your FlySky, and then I remove all the other things here. It's your decision what you want to use. Just test it. Oh yes, no GPS, no coordinates, no compass, no heading, nothing. Just timer and current and voltage and RSI. So you can add call sign, so other people that you see your video signal can see what video signal is coming from, and then you can save this as config for later use. And then you just need to write this on your on your OSD, and then you're already finished for what you need. In the second part I show you how to flash the firmware of this Flip32 all-in-one. I choose you can choose the Cleanflight version here for NAS, or you load you choose your local file, and I had my local file here, the hex file I choose, then I say open, and now the file is loaded. To upload it, I choose the flash firmware button, and then the latest version will upload to the board. You don't need any boot things or something else, just upload the latest firmware version. After this I can connect to the configuration and see already my board and moving very well. Battery voltage and so on we must check first. I activate the UART2, just for use, and reboot the board. Then I use in the configuration quad X. One shot is already activated VBAT. I use a PPM receiver and so on. I think a lot of tutorials for use of this. For current, sorry, I did an error here. Don't enable support for legacy, so you get wrong measurement. Disable this, and it works very well. So sorry when I stop here, but I think the most of the things you see in this Cleanflight configuration you find in other videos, so it's not very interesting for you. I would like to thank you for watching, and if you like it, then comment please, or send me pictures at Thingiverse when you build my frame, or if you have questions for the flip all-in-one, then just write me a mail or something else. So hope you